Okay. Are we ready? Hopefully we're ready. Hopefully we've got something on a screen. Great. This will get started. Okay, so we've spent a long time so far this term talking about modeling things in Rhino, but remember what I said last week. I'll sort of start this week with where I left off last week, which is the picture in your mind to have when you're using the digital world or digital tools or anything on a screen that's only on a screen, is that it's a heist. You get in, you do some stuff, you get out. If you fail at any one of those stages, you haven't really used the tool very well. So if you don't ever fire up a computer, not very useful. If you fire up a computer and then spend your entire life in 3D modeling software and never get out, not very useful, because you're going to get locked in jail forever and ever and ever, and it will imprison your mind. If you don't actually get the stuff done that you needed to get done, can you all hear me? Oh, no, I'm on now. Great. If you don't actually get the stuff done that you needed to get done and then get out, then the whole thing was for nothing. So we're moving on to probably the most important part of the lecture course, which is not just how do you model stuff in Rhino or 3ds Max or anything, but how do you get stuff out of this digital world that's useful for the real world? And the first part where we're going to start is about drawing. So in order to make anything, in order to make any impact on the world, at some point you're going to need to draw what it is that you are designing. Is everyone happy with that as a concept? I mean, effectively, what's really interesting about architecture is the thing that you create as an architect, most of all, of anything that you ever produce as an architect, is not buildings, but drawings. Your job as an architect is to draw what someone else might go on and build. In that way, in some ways, there's a really interesting parallel with composers. So if you compose music, what do you produce? You produce a score, and then you give that score to a conductor and an orchestra, and then they produce the music. So your job as an architect often comes down to, can you communicate to someone else what you want them to do? And generally, the way that we do that is through the medium of drawings. So this is a little project that I want to use as kind of a case study. So it's a bench. It's not a building. It's just a piece of furniture. The first thing, the reason I want to pick this is because it has a digital element. It has quite a significant digital element. Like, that is not the kind of object that you could just sit down with a pen and a pencil and simply sketch freehand in one go. Now, of course, you could do it by hand. Absolutely, you could do this by hand. And in fact, there's furniture from the 1700s that's way more complicated than this, way more intricate, way more detailed, has way more curves to it, and they didn't have computers then, right? So just because I used a computer doesn't mean it was impossible to do without a computer, but the computer was a tool, and the computer allowed us to do all sorts of things about making this particular bench. Like you can see there's an animation of how it's supposed to be put together. So now I can communicate to someone else how they're supposed to build it, which is part of what my output is. And so, looking at this, one thing of the outputs is a prototype. So there's a physical object. I don't actually know where it is. It's probably in someone's garden somewhere right now. But there's a physical object that we built as a prototype. But there's also a set of instructions that you could then use elsewhere and do it again. It was a lovely, lovely project, a group project, 5 of us working quite hard on this one. And these are the drawings that we produced as part of this project. And what you'll notice about these drawings is a few things. Just shout out something that you can notice about these drawings, some element that you can see that is used to communicate something or some intent to someone else through these drawings. A jigsaw? Oh, it's like a jigsaw. Yeah, it is like a jigsaw. It's a set of sort of instructions, isn't it, about how to build the thing. It's kind of like the picture on the front of the box, and then you open it up, and it's all in pieces. There's a very famous company that make furniture that do these kinds of things as well. You heard of that? Begins with an I, from Scandinavia. IKEA, is that what you said when you were looking? Yeah, you were like, oh, it's an IKEA. It's kind of like an IKEA drawing. Yeah, because it's a set of instructions about what you want someone to do. Now, obviously, the interesting thing about this is at the moment, you know how to model that object in Rhino. In fact, pretty much, I think I'd be surprised if any of you, if you just sat down and looked at the Rhino model for this, you'd be like, oh yeah, I could do that. Because at the end of the day, it's a shape and then it's some contour lines. That's all it is. It's like cutting up a shape that I lofted from some curves. And we'll literally run it through later as a case study. So you could definitely model that in Rhino, but right now, you couldn't click a button and produce a drawing like that, like an IKEA catalogue drawing, an IKEA instruction drawing. Any other things you notice on that drawing that are helpful for people? Have a look on the left-hand side. What are the dashed lines? They're measurements, yes. I mean, the specific term is dimensions, but yeah, measurements. They tell you how big this thing is. And that's really helpful. Why might that be helpful if I had a piece of paper that I printed this out on? Remember, think back to the very first lecture that we talked about. My golden rule when you're modeling in Rhino is put a person in it, because before you had the person in, you had no idea how big anything was, right? So when you produce drawings, they've got to have a scale, and they've got to have some understanding of how the real world size of what it is that you're trying to get across. So those dimensions that you see there are in millimeters, I think. I'll see if I can I zoom in? Yes, I can. So you can see there that the width of this chair is going to be 600 millimeters. So I know how big it is in real life. Anything else? I'll zoom in so you can kind of see down here. What do you notice about the lines? Think back to year one. You had all those fiddly pens. Why did you have multiple pens? Did you do this in year one? You had to buy like a thin pen and a thick pen and maybe a medium pen. What do those pens actually do? What do they mean? What's that? Height references? Ah, yes. So what those lines do is they kind of give you a sense of depth, don't they? Yeah, absolutely. And the other nice thing about this drawing is, do you see there's a kind of a thick line around where there's a silhouette, and all the other lines are thin. And if you think back to year one, you probably got taught this. Some people teach it. It's called the spider principle. Like if a spider could crawl across a crease or a line in your drawing, and you could still see it on both faces, then that line's got to be thin. Whereas if a spider crawls around a corner and it disappears, then that line has to be thick. And what it does is it gives you this kind of silhouette that makes this whole thing feel really, really 3D, even though the lines are completely flat. So the whole thing kind of comes off the page at you, and that you can believe that this thing is 3D without really, I haven't added any shading, any shadows. In fact, with line weights alone, you can suggest to people ideas of depth. This one on the right-hand side is more than just a jigsaw. It's actually, those are the exact lines that we then sent to the CNC machine in the workshop. So we started, bottom left, with a drawing. We started with a digital drawing. Then we took those lines and we literally exported them as, I think, a DWG file. And we put them on a memory stick. We took them to the workshop and we said, here are the lines that I want to cut out of a single piece of 1,200 by 2,400 millimeter piece of plywood. We bought a piece of plywood and we loaded those lines on, and those are the lines I want the computer to cut. And the computer controls this drill that then exactly jigsaws out the lines that you have drawn. And then you can see there that the lines that were in the computer have now become real. They've become a physical thing. That this is the leftover bit of wood when we were finished. Yeah? And then the bits that you actually want, you can then start putting them together, top right. Are you happy with that as a process? There is no way you can have those lines that you want to send to the CNC machine until you've done the drawing. So the drawing is a critical part of getting from the computer out into the real world. So this is all about getting drawings out. This is what we're looking at. But the reason we're getting drawings out is not just so that you can get a mark at the end of your year on representation or something. The reason we're getting drawings out is because that's the job of the architect. The drawings that you can get out of a digital process can also be used to explain the process. So this is a diagram of a particular process of how I went from a very simple shape right in that top left-hand corner. This is literally 3 shapes lofted together. And it gives you this kind of interesting piece of geometry. You know how to do that. You can loft some shapes together. And then the diagrams simply say, okay, well, cover that with some random points. And then those random points then become seeds for a process called Voronoi fracturing, which is a kind of fairly standard kind of algorithm that was invented in probably 60s or 70s now. Then split that apart, use the points to make a sort of a structural mesh. And then this is actually ends up being something that can be 3D printed as an object. So the diagram of the process then helps to understand, take people into your process. Drawings can also be incredibly evocative and incredibly beautiful. This is a studio in Japan called Atelier Bow Wow. Just hands up if you've come across Atelier Bow Wow's drawings before. Maybe one of your tutors has given you them as a precedent and said, look at these drawings, aren't they amazing? Yeah. And they are lovely. The lovely thing about these drawings is the level of detail and scale and inhabitation. Like, everything is not just accurate, but you can see there's dimensions on the bookshelves. So the person drawing this has engaged with not only the whole building, but they've engaged with, well, if you're going to store books on these bookshelves and they've got to fit in this particular space, this is how many bookshelves you can fit in. So they've gone to this kind of incredible level of detail, which shows not only that they're in control of their design, they know how it's going to work, but the drawing process got them there, and they're showing what it's intended for, what it's going to be used for. And these drawings do not come about overnight. There is no button you can click in any digital software. AI doesn't do this, by the way. You cannot get this out of AI. You could try, but it will not happen. And if you did, none of this would make any sense at all. So it's not worth trying or wasting your time. But these drawings take time and effort and understanding. And the process of drawing actually makes you understand your design more. So you go, hey, well, there's a blank space here. What am I going to fill it with? Oh, then it's going to become, a veranda or whatever. And then each one of these, you can see here, the resolution isn't particularly good, but each one of these is a timber beam that you can literally see it being cut through. And then there's the technical information encoded in within the drawing, as well as the inhabitation and the sort of sense of it. I really like this drawing. What you've got on the left-hand side is the whole thing at a scale of, I think it's 1:30, but I might be wrong. It's a sort of slightly odd scale. And then the one on the right is a cutaway, or basically a kind of zoom in on one particular part, which is at 1:10. So you can put the technical details next to the whole, and the whole thing works as a piece of art as well as a piece of instruction about how someone's going to build the thing. Here's another Atelier Bow Wow. I just love their drawings. I think they are gorgeous. And what I love about them is the line work is the medium. They've done so much to make sure that the line work and the line weights all match up. And actually, all of that sense of depth and inhabitation and sort of you feel like you can understand where the light's coming from even, just because they've used line weights correctly. It's a language, actually, that line weights language. So I'm going to show you a little bit now. This is a project. I wonder if I can, there we go, turn this down. This is a project of mine. I did this in my second year undergraduate. Hang on, go away. So it is possible to do some quite amazing stuff the first time you sit down and use this software. In fact, weirdly, I think back and I think the first time you use it, everything's new and fresh and exciting, and that's probably when you could do some of your best work. The idea is that this is a sort of 1930s animation from Walt Disney called Mickey's Trailer. It's Mickey Mouse, and he's got a caravan. And the idea behind a caravan is everything's like very, very careful. And what you can do is you can sort of fold the bed away, and then it's going to become like a dining table. Or you fold out the, whatever, let's see. There's a kitchen here, and there's Mickey's obviously making breakfast, but he's making coffee or something, it seems. And, oh, this is nice. He's sort of got his bucket coming out the window. He's going to pick up some water. He's going to boil the water on the stove. Lovely. Oh, that's nice. He's driving past some cornfields. He's going to cut some corn. But the interesting stuff comes in a second when the caravan starts turning into other rooms of the house. So basically, you've got multiple rooms of the house, all encased within one very, very small object. So what I did was I said, well, wouldn't it be great is if I could draw how that actually works, how you could fit all these different rooms into one tiny caravan. So as you go along, you'll see a few different things here. Obviously, you can see the car that's pulling the caravan along. We're inside. There's a couple of bunk beds. There's an alarm clock. And then the alarm clock's going to go off, and it's going to kind of pull the duvet off Donald Duck and wake him up. And then it's going to wake him up. And what's important is that the beds, you see the beds are sort of supported outside of the wall. They're hanging off the wall. And as soon as he jumps off the bed, they're going to fold back into the wall, like a sort of Murphy bed type thing. And then they've got to get ready for breakfast, because Mickey's making the breakfast, obviously. Say, hey, breakfast time, we're ready. So now the beds are going to fold away. And they kind of switch around, and then it becomes, oh, it's a bathroom. Where did that come from? Suddenly there's a bath coming out of the floor. And not only that, but it's like, it's inflated. How cool is that? It was kind of waiting under the floor, and then it kind of inflated. And the wall on the left that used to be 2 bunk beds is now a bathroom. Is now a sink with some taps. And he's having a lovely little bath, and he's washing his bum. Oh, the birds are at the window. Shoo, go away. Not happy with you. And then you see, as time goes on, Mickey's ready to change this around. And so the walls all flip over, and now suddenly it's a dining room. Hey! And now breakfast is ready. Donald Duck sitting there. He's calling for Daffy. Who's that? Not Daffy Duck. And off they go. And now they're having a nice sort of breakfast on a dining table. So, I mean, we could keep watching. It's a really, really cool little animation. If you want to get into 1930s animation, very much recommend it. And so this became a drawing. And what I want to do is I want to show you that this is the final drawing on the left-hand side. What I have here is the Rhino file from which the drawing came. And I will basically just show you how this file works, because half of the project was about how to work out how this stuff actually happened. So what you'll see here is these are, I'll just zoom in on this bit here, and I'll use my zoom to selected tool. Here we go. So clearly at some point, there are some beds folding out of the wall, and then the beds kind of fold away, and then the wall flips round, and then it's a bathroom, right? So what I've decided to do is I've said, well, it'd be really good to try and understand how that works by modeling it in 3D. So everything that you see here, I'd be really surprised if you couldn't probably figure out how most of it works. So what have we got here? Super simple. It's basically a box, and then the pillow is just a couple of lofted lines. And then we've got some filleted boxes here, and quite like this. This is kind of nice. We've got this kind of like cylinder which is kind of been squeezed at the end to make it a bit thinner at one end. And then you come around, and obviously the bathroom's got to be upside down when it's stored, and then it flips over, and then you've got things like a cabinet, and the cabinet's pretty simple. Again, it's basically a box with a little hole cut into it, and a handle, which is just a sort of squashed sphere. I think I remember this taking me quite a while. This is basically just a whole load of cylinders and pipes, all just sort of sitting next to each other. And it's possible, it just takes time. You've just got to sit down and put some heavy metal music on and kind of focus in and just get your head down and do it. And then similarly, wouldn't it be great if we could really understand how all these bits come together to form a dining table? And now, clearly, this is me just trying things out. So what I'm doing is I'm laying out these items in my Rhino world, and I'm using them to kind of like try, oh, well, if I flip this over, what happens? And if I put this behind this, then when I flip it over, which way around is it going to be? And you can see here, there's a kind of starting point to some of these ideas. So, you know, I want the bathroom wall to be able to flip. And then, well, that probably means there needs to be some kind of gear mechanism behind it. So maybe let's have a go at modeling that. And yeah, this is a few days of work, but it's a few days of work modeling something that's super clean, and it really helps me to understand what I'm trying to do here. And I'm ending up using Rhino almost like an animation tool, because I can sort of model these little snapshots in time that I've taken from the animation that I'm basing it on. And I can say, oh, well, how did that work? And where did that move? And then where it got to is this kind of monstrosity here, with some really, really nice ideas where exactly like an IKEA instruction manual, well, what we could do is once it's modeled, we could kind of explode it out, and then you can see all the bits that go into making that thing up. So this is the window frame, and obviously you'll remember when you looked at the caravan, there was these kind of awnings. So I know that there's going to be a frame for that, and then there's going to be a sort of a window surround that goes over the top, and then there's a window frame, and then there's some curtains. I can see the curtains in here, so I need to be able to model those. And pretty much all of these are basically boxes or lofts. And this is why I spend all my time at the very beginning saying, you don't need to know thousands of commands. What's this curtain here? Looks really complicated, right? It's just draw a squiggly line at the top, draw a squiggly line in the middle, draw a slightly less squiggly line at the bottom, and then loft between them. And then you've got a curtain shape. I mean, I'm making it sound simple, but you understand that the principle there isn't anything that you haven't ever seen before. Are you happy with that? It's just mostly a matter of time and focus. And I found a little picture of Mickey online, and I traced him round, and I put a picture of Mickey in. And Mickey is simply just a flat, he's just a flat two-dimensional object, because I can't model Mickey, because Mickey is two-dimensional. So all I have to do is just set my view up, and then just literally, I'm just going to paste in this thing. And the thing is, as I'm working, I'm also thinking, I need to get this out as a drawing. I'm not just modeling it for the sake of modeling it, although it's fun. I'm modeling it so that I can create a drawing. And so as I'm going, I'm not just thinking, oh, how are the wheels held on with some bolts? Obviously, there are some bolts in there, and there's a wheel. But I can then explode that out, and then I can set up my camera in such a way that I can see all of this stuff exploded out. Are you following so far? Cool. Once it's modeled, that's when the interesting stuff happens. Because the modeling is really half the process. The next part of the process is I need to get flat two-dimensional lines out of this drawing. And we've already seen this. I showed you a couple of weeks ago. But what you can do is you can select the lines that you want in the view that you want. You have to have set up the view correctly. And at the moment, I'm using a parallel projection, not a perspective one. You get to that by going set view and then isometric. And then you can just pick one of the sort of northeast, northwest, whatever, and then rearrange your camera. So it's an isometric view. I'm going to select everything here, and then I'm going to type make 2D. And that gets me from modeling world into flat drawing mode. There's a few options here, but the options that I want available to me are, I want to use this view, parallel SE. I want to make sure that I create a scene silhouette, and we'll see why in a second. I don't know if you can see on this little preview here, when I tick on scene silhouette, it makes the outer line much thicker. What it does is it allows me to have a layer for my silhouette lines and a different layer for all my other lines, and then I can assign different line weights to my silhouette line as opposed to all my others, which basically means that the computer can do the working out or do a bit. It isn't always very good, I have to say. I usually have to tell it off sometimes. No, that line should be on that layer or whatever it is. But the computer is going to try its best to do the thing, which is if the spider crawls across a line and you can see it on both sides, then the line will be thin. But if the spider crawls across a line and disappears, then that line has to be thick. It's like a silhouette. So the computer's going to try and do that for us. I could put on hidden lines, but that will make my drawing really, really busy. And what you'll notice, if I head back to my presentation, none of these drawings have hidden lines in them. So they're really busy already, but they're only the lines you can see. There's nothing. If there's something in the way, there's something in the way. You can't see through things. So the temptation often when people use Make 2D is that they model less and with less certainty, but then you tap on hidden lines and you get tons and tons of lines and you think, wow, I've done loads of work. Not quite. The work comes from actually modeling stuff the way it needs to be and setting up your view the way you want it to be, and then working into the details. And sometimes that just takes time. Hidden lines, and I'm going to say group output, that's fine. And then I'm going to have an output layer, which is, object properties. What I want to do is I want to maintain source layers. And what that will mean is as I've modeled, I've organized all of my objects onto different layers. And so I've got a layer for the chassis of the caravan down here. I've got a layer for the wheels. And you can tell they're on different layers because they're different colors in my Rhino viewport. So I've assigned different colors to the layers, and anything that's green is a wheel, and anything that's dark blue is a piece of chassis, and anything that's light blue is like a part of the bathroom, for example, or whatever. So I've kept everything really organized, and what I want to do is when I move that into my 2D world, I want to keep all of that information. I don't want to lose that information. So I'm going to make sure that I use object properties and maintain source layers. And I'm going to output this to a layer called Make 2D, and then I'll call it isometric. There we go. So I press OK, and then it chugs away for a little while, and it'll give me a little progress bar down the bottom. Now this is a pretty complicated model. There's a lot of geometry in here, but it's quite neatly modeled. There isn't any like huge black messy geometry which is just kind of too heavy. So it actually doesn't take that long. And we are pretty much done, I think. 99%. Still thinking. just got to finish its last little bits. Whilst it's thinking, any questions on what I'm showing you here? Did you think that would be possible? That you could basically just sort of sit down and model basically anything that you see now? Anything where you're like, I have no idea how you do that, that might be interesting to you in terms of, because you're also starting to model your buildings now, and you might be modeling them in quite some detail, and there might be some things about them that you're like, well, this is a bit weird, I've never seen that before. How would I go about modeling it? Is there anything that you can see that you're like, oh, it'd be useful to know how to do that? Yeah. Yeah, it's a really, really good, useful thing, because you'll make something and you'll realize, oh, I should have put it on that layer. Yeah. You select it, you find the layer. Oh, there we go. This is finished. You select something, you find the layer that you want to move it to. You right click that layer, and then there's an option called Change Object Layer. And what that will do is whatever object you have selected, it'll put it on that layer that you've just chosen. Cool. So here we are, and what I'll do is I will come out of my parallel view and go into my top view, because the thing that Make 2D does is it makes a two-dimensional flat set of lines out of whatever view that you just took, but it will put it on the ground plane. It won't put it in the view that you were in, it'll put it on the ground plane. So now I have to come into my top view, and basically, here's my 3D stuff all in my top view, but here are the lines that I've just made. I'm just going to move them out of the way just so they're not sort of getting in the way of what I'm trying to do here. But these lines here, what you'll see, oh, that's why it took so long. I left hidden lines turned on. Do you see? I'm not sure if you can see very easily, but there are these very, very faint dashed lines that are showing me through all of my walls. Now, because I left the tick on, that's actually not particularly helpful to me, because what I'm going to do is, this is already a really, really busy drawing. Already the lines are kind of like, there's just too much going on, and I need to be able to focus people's attention on just what I want them to see. So what I'm actually going to do is turn those off, but you can basically see through things at this point. And it's kind of fun to play with, but I suggest for your own discipline that you don't tend to use hidden lines, because what it'll do is it'll make you think you've done more than you actually have. And real architectural drawing, you don't see through things in real life. You only ever see what you can see. So here we are. I will head down here, and here's my Make 2D isometric layer. So everything has now gone onto this layer, Make 2D isometric. There's a layer it's created called hidden, and I'm just going to turn that off. The difficulty is that now some of the lines have kind of disappeared a little bit. I don't know if you can see, but Make 2D isn't perfect. If you haven't modeled something exactly right, Make 2D will just kind of like freak out sometimes. So here's a good example. Here is my kitchen cabinet in the kitchen. And what's happened is that kitchen cabinet is kind of interfering with the wall of the caravan. It's basically what's happened is I've modeled it and I've like shoved it along a little bit, and it now goes through the wall. And I don't really want it to go through the wall, because that's not what kitchen cabinets do. They go up against the wall and then they stop. So what I can do is I've got two options at this point. I could go back to my model and fix it and then run my Make 2D again, but that's going to take like 2 minutes. I could do is take 10 seconds to just fix the lines super quick. So what I'm going to do is going to come into my visible lines. I'm just going to collapse my hidden because I don't really care about those. I've got visible lines, and what you'll see here is there's a red layer called kitchen, and I come into that layer and I'm going to draw the lines that are missing. And it won't take long. In fact, it's done. So now I've got my lines sorted. I'm going to come up here and I'm going to do extend dynamic, and I extend that line all the way up to there. You get the idea, right? You can basically now start to sort of tidy things up. But because we've modeled this super carefully, we've now basically got our IKEA instruction manual. All the way down to, the cogs and the gears, and they're kind of working. It's kind of nice. And literally all this thing is like a few straight lines that I've then arrayed in a circle and then lofted between two, a small one and a big one, and then suddenly you've got a cog. Now there's a lot to it, but it's fun. I kind of like being in this world, and now I especially like being in this world where this is now locked to two dimensions. This is my drawing, and you see I've moved from 3D world to 2D world, and now I've kind of made some decisions. I've locked it down. I can't change my view anymore. I've locked it down. I've made a decision, and I'm moving on. Now I'm in 2D world. Now there's a few things we need to make sure are working in 2D world. And one of the things that's really helpful in Rhino is that you now can stay completely within the Rhino world. You can stay within the Rhino ecosystem, and we can say, there's a little plus down here, a little plus button. If I press plus and say new layout, this will give me the same options that you have in CAD. So in CAD, you have a model space and paper space, and in Rhino, you have model space and layout space. They're exactly the same. So here we go, name page 1, I'll call this isometric drawing. I'm going to use Rhino PDF, maybe we'll say this is an A2 drawing, and looking at it, it's going to go on a portrait piece of paper, not a landscape, so I'm going to make sure this is portrait, and press OK. And then, what happens is I get this. Now, this is a frame on my page, and that frame is like the CAD viewport. So if you're familiar with CAD, what you do is you double click inside it and then you're in the model space. And you double click outside it and you're back in paper space. You switch between the two. I'll give you a little example here. I can double click inside, double click. And then I can zoom in, and here's my top view. And I can find, this is all my line work. This is all the stuff that I was doing. Just give it space to breathe on the page a little bit. And then I'm going to double click outside, and now I'm back in paper space. So now this is kind of locked to the paper. And in fact, what I'm actually going to do, I'm going to take this view, this detail view, this view frame. I'm going to change the layer that it's on, just put it on my default layer. So this is an example. This is answering your question. You select an object, you find the layer you want to put it on, you say change object layer, and now that's become black. Now it's on my default layer. However, I don't want things to be light blue and green because that doesn't print very well. So it would be really nice at this point for me to have control over things like the color of my lines and the weight of my lines. Because if I've got control over that, I've basically got the ability to do my entire drawing within Rhino. So what I'm going to do is I'm going to expand out my layers panel here. And what you'll notice when you're in a layout view, this isometric drawing layout view, you've got a few different options. The first one is I'm going to come down to the drop down for the view. I'm going to turn on print preview. And when I turn on print preview, not much seems to change. But what you'll notice is the first thing that happens is my layout, my detail view, my kind of viewport layout disappears. It's got a little sort of border there, and I click print preview and it goes away. And because a layout view, a detail view within a layout, isn't going to print the actual border itself. So I don't need to see that. So it's basically giving me a little intro as to what it will look like when I print this out. The next thing you'll notice is if I expand out the layer panel when I'm in a layout view, then what you'll notice is each layer has a color, but it also has a diamond with that same color on it. So a color, this is the color of the layer in my model space. I come back to here. This is my 3D model. I've laid it all out. I've put everything on the right layers. I've got control over everything here. But these layers have now followed through. That means that if I look at my bedroom wall, for example, that's colored red, I can go over here and you can see bedroom wall, colored red, there it is. So everything in red, all of this line work is red, but it's also red over here where it says print width. It says print width default, line type continuous, and it's got a little diamond with a color. So I'm going to do a couple of things. The first thing I'm going to do is I'm going to make sure that I've selected all of these lines, and I go into my properties for those lines, and I want to make sure that everything about the color of the lines, the weight of the lines, the line type of the lines, whether it's dashed or whether it's solid, any of those things is controlled by the layer that it's on. Because I've already organized my drawing, I know everything's on the right layer, and what I want to do is now just make the same number of changes to the layers that I have, and that will affect my whole drawing. I don't want to have to click every single line and say, this line should be thick, this line should be thin, this line should be thick. If you use Illustrator, that's kind of what you end up having to do. Have you done that with Illustrator? Yeah, you go into Illustrator and you go, right, okay, I've got to do my line weights. Select the line, say how thick it is. Select the next line, say how thick it is. We haven't got time for that. The computer can help us with this. So we've organized things properly, and that means that I'm going to come in here, I'm going to make sure the layer varies, display color is set by layer, display mode by view, line type by layer, line type scale 1, that's fine, print color by layer, print width by layer, section style by layer. Everything is by layer where I have an option to do so. So here we are, come into my drawing, I'm in print preview mode, so I can see now that if I come over to these lines and I take the bedroom wall lines, I'm going to keep them red in the model, but I'm going to make them black when I print them. So I'm going to click that diamond, I'm going to drag that down to be black and press OK, and then, oh, what's happened? Who knows? Well, it's because they're not on the right layer. It's because I was looking at the wrong Make 2D. Ignore me. This Make 2D is an old one. That has nothing to do with what I'm doing. This is the Make 2D. Make 2D isometric. That's the one I just made. So I was looking at the wrong layer. Let's try that one more time. Bedroom wall. This red color, I'm going to leave it red in the model, but I'm going to turn it black when I print it. And now those lines have gone black, but if I go back to my model, they're still red in here. And this is incredibly useful. This is a kind of a feature that people mostly overlook. And it gets a bit confusing, but think about it like this. When I'm in model mode, I can't see how thick my lines are. Because a line is just a line, it's infinitely thin. If I'm looking at these lines in a model space, I have no idea whether they're thick lines, thin lines, whatever. But if I have a color code, I can use the color code to tell me whether I know they're going to be thick lines or thin lines. Does that make sense? So this is a red line because it's on the red layer, but when I'm in my paper space and I have print preview turned on, I want it to print black. And this is how I set up all of my drawings. I've got a color to make sure I can keep track of what layer my lines are on, but I've got a print color that's going to be different. And you can literally see the difference by toggling on and off print preview. So here we are. It's red when I don't have print preview on and black when I do. Okey-doke. Now, I can carry on and I can basically take, and to be honest, all of these curves, when I print them, I pretty much want them all to be black. So I can see all of these lines, I'll take them, the color is going to be black, and then I'm going to put print preview on, and now suddenly I'm looking at a black and white drawing, even though the layers still have their colors. It's a good start. However, what you'll notice is all the lines are the same thickness. I've got none of that depth. And anything that looks like a thick line really is only just come about because it's like lots and lots of lines all in one place. There we go. I quite enjoyed the cogs in modeling all of the mechanisms. And the nice thing about these lines is you can kind of zoom in infinitely. They never get any thicker or thinner. They're just infinitely thin lines. The problem with a drawing is that you want the lines to have some thickness. So what we can do is we can come in here to my scene silhouette curve, And I'm going to do exactly the same thing again. I'm going to take all of my scene silhouette curves. I'm going to make them black. Boom. But I'm going to make sure that the print width of my scene silhouette curves is now set to something thick, like 0.25. And you won't notice in the first hand what's happened, but then when I zoom in, suddenly I've now got thick lines and thin lines. Making sense? And this is what I mean when I say that sometimes the computer gets it wrong. It's kind of done a really good job with the outline of the caravan, but it's not done a particularly good job here. Like, if that line is thick, well, surely that line should also be thick. And surely this line should also be thick. But it's a starting point. The chassis is looking quite good. I mean, if you zoom in too much, you kind of start to see some weird little weirdnesses. But it's a good starting point, and I can go in and I can fix some of those. And I could fix it literally by picking a line, say this one here, and I could say, well, that's on the wrong layer. I want to make that part of my silhouette lines, which is going to be a scene silhouette curve, wheels. I'm going to say change object layer, and now that line is thick. Cool. And basically, once you then sit down and do the rest of the fixing of those line weights, which are the principles you already know. It's basically just select the line, move it to the layer that makes sense to you. And I've got an organizational tactic here where I can basically say all of my visible curves, or these ones, I'm going to give them a line weight of 0.13. There we go. And all of the silhouette curves, I'm going to give a thicker line of 0.25. And already, there's a kind of some sense of depth going on in this image. You can kind of see the difference between the outline and the actual line itself. And this is the point at which I really do have something that looks like an IKEA instruction manual. And I can take that and I can export it to a PDF, and I can bring it into Illustrator to do things like coloring in. And it's 10 o'clock. And yet all that hard work in the modeling has now suddenly paid off, and I've got 2D drawing that I've actually had in my mind. Do you see how useful this can be? My guaranteed piece of advice to you. A screenshot from Rhino is worth like 1p to your tutor. There's something that's worth even less to your tutor. If you come to your tutor and you say, I want to discuss my design, and what you do is you have an open Rhino model and you do this. Hey, look, what's going on here? I'm not sure what's happening here, blah, 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 blah. I don't know, this could be there or this could be that. You can't have a design discussion with someone with just an open Rhino model. It's almost impossible. You can't do it. If your design tutor allows you to do that, that's fine. But it's nowhere near as good as you've stamped a 2D drawing. You've made a decision and you've laid out a 2D drawing of your object that you want to make. And you've put that in front of your tutor. And now you can do this in about 10 minutes just by making sure that your layers are organized. And then all of the layers that are just called curves, you give a thin line weight to. All the layers that you called scene silhouettes, you give a thick line weight to. You print it out, A2, whatever it is, A3. You put it in front of someone, and then suddenly you're having a conversation about the architecture. You're not having a conversation about, whether you use the right silhouette of Mickey in the model or whatever. Does that make sense? Any questions on that before we have a quick break? Yeah?
Is there a way to export into ASOS
There is. Is there a way to export the lines from Rhino to Illustrator whilst maintaining the layers from Rhino? And the answer is you use the colors. So this is another reason why every different layer has a different color. Because then in Illustrator, what you can do is select all the lines which have a particular color. So select all the lines that are the same color as this one and pick one. And then it goes, basically, all my green lines are now selected. Now, Illustrator doesn't quite have layers in the same way, but I do believe in the more recent versions, I haven't done this recently, the easiest way is color. The other option is, I think this may exist now. Yeah, there you go. I think you can do order layers, and then it will actually include the layers of the line work. It's worth checking, but the easiest way is just to use the colors to identify the layers. But I think in the more recent versions, it is possible. It might be worth Googling. I just use colors because it's easier. Any other questions? Yeah. How did I? Oh, as in this wall has like a curvy cut in it, you mean? Oh, these like curvy lines here. Oh, yeah, well, I just modeled them. Let's have a look in 3D. So basically what I did was I started with the wall here, and I dragged it this way, and I just drew a line. All this is just an open curve. It's just a straight line, but then I added it to a layer that has a dashed line display mode. So it's just on a layer, and I think it's literally called dotted. Let's find the layer. The layer is called dotted. There you go. So there's a layer just for those lines, and it's got a line type of dashed and a color of black. And so it's literally, you can just, when you do make 2D, it exports lines as well. So those kind of annotation lines, they just come with it, which is super helpful because you can use lines and surfaces and boxes, and you basically sort of, when you make 2D, you kind of like put all of those together into one set of lines. But if you've kept your lines organized by layer, you could then choose later to turn them on or off, or change their light type or whatever. There's a super useful thing. I'll just come in here. I will go to properties for my detail view, and I will lock that. And then come in here. If I double click here, there's a useful little command called arrowhead, which adds an arrowhead to a line. So now I can do annotation with arrows as well as just static lines. Annoyingly, as I zoom out, the arrowhead kind of stays the same size wherever you are, but it'll print at a specific size, so that's okay, and you can control exactly how big it prints. Now, just before we break, your task, and I don't want you to feel like you have to spend, I think this is probably 3-4 full days of work to get to this kind of drawing. So I want you to just take that expectation out of your head. But the third task in the small tasks that you've got, and it's on Moodle, it's in the module guide, so you can read about what you need to do. But you've done some mapping, you've got into the digital, you've modeled a thing that you've got on your desk. But the next thing that you're going to have to do as part of your portfolio, or as a little task at the end of your portfolio, basically, is to produce a two-dimensional drawing with line weights, with all of what I've just shown you, of the object that you modeled. Does that make sense? Now, for most of us, if we've modeled it cleanly and we've kept control of our layers and we've got an understanding of what it is that we want to produce, you could basically set up a plan view, do a make 2D, you've got a plan. Set up an elevation view at the sort of back or front or right or left viewport, make 2D, you've got an elevation. Sort out your line weights, you've got a PDF with line work of the model that you've just made. And it doesn't have to be much more than that, but you can also go into quite a bit more detail. You could annotate it, you could add dimensions, you could add measurements, you could add more interesting line weights, more than just what the computer gives you. And you could do a section cut through it, which with a clipping plane. We've seen that in previous lectures. So the idea is that you've already got a model to do this with, this is kind of another practice about how to turn a model into drawing that you could then print. And by the way, I will just demonstrate that printing this layout is as simple as file print. Let's go file print. It's going to have a think because there are about 1 million printer connections here. Oh dear, it is taking some time. There we go. I'm going to print Rhino PDF. I'm going to use the layout page size. I'm going to use the output color. It's going to be print color, not display color, because if I tick display color, then it comes in my layer colors rather than my print colors. Basically, I want to use the diamond ones, not the square ones. I'll do vector output, isometric drawing, and scale to fit. And I'll press print. And basically what that's going to do is use the Rhino inbuilt PDF printer. I'll put it in my downloads. And over to here. And I'll open that up. And then you can just double check that this process gives you a two-dimensional set of line drawings that I'd be pretty happy and be pretty content to put in front of a tutor and have a conversation about how my building might be put together, whatever it is. So it's not a big process. And what I'd love you to do, ideally, to get to the habit of the last maybe half an hour before your tutorial, is you stop modeling and you do this, and then you've always got a drawing to put in front of someone, and then that drawing can evolve. Cool? Let's take a break. We'll be back at 20 past, and I will talk you through another case study with a little bit more nuance to it. And I will stop the recording here.